record again. All right, so moving on to extra credit. Okay, this is gonna be your lab question as well. It's gonna be, I think it's gonna be next week. This week it's gonna be free fall lab. I'm gonna post it hopefully tomorrow. Right, I'm almost done writing it up. All right, so this car is going from 60 miles per hour. We're accelerating from a stoplight to 60 miles per hour. Stoplight to 60 miles per hour. Okay, so I goof this up. Initial speed in this case is gonna be 0. It's gonna go up to 60 miles per hour. Okay, this is the reason why I like solving problems live as opposed to doing them at home, because it's tough to pay attention when I'm working on my own. All right, so the way I've done it, which is still pretty accurate. Evidently, the car is going at 60 miles per hour. It's come to a stop. It's going from 60 to 0, and which means that I'm looking at the acceleration at that point. So what that means is this fuzzy die is going to be moving forward. That's the case when you put the brakes on. So in the way I solved it, the vehicle is moving at 60 miles per hour, so that's going to be 26.78 meters per second. Within 8 seconds, it's come to a stop. So which means that what is the angle if that's the case? And so I kind of reversed the problem. And still, all right, so the first thing you have to do is you have to do a force diagram. So it's got weight, and it's going to induce a tension on the cable. This angle that you're looking at, which is theta, is going to be that angle right there. So you have to place the angle right there. All right, so now we're looking for the angle. And in this case, the car is accelerating in the forward direction. So I would just sum up the forces on the x direction first. So what do we have along the x direction? Along the x direction, you will have the component of t. Along the x direction is going to be the base of the triangle that you're looking at. This is the hypotenuse, this is the base. So it's going to be t times the sine of the angle. And along the x direction, we don't have anything else. That's it. Okay, so that's going to be, and that force is going to be responsible for the acceleration along the x direction. So that's one equation. I'm just going to box this. So we got one equation. All right, from this equation, can we figure out theta? All right, so mass is not given to us. So the answer to that question is no. We don't know t, so we won't be able to. Okay, we still have 2 unknowns, which means that we have to come up with one more equation. This time, just sum up the forces on the y direction. All right, so just sum up the forces on the y direction. Yeah, in the upward direction, t has a component. All right, so this is going to be the adjacent over the hypotenuse, so it's going to be t times the cosine of the angle. And along the negative direction, you have w, which is the same as mg. So mass times acceleration on the y direction. That force is going to be responsible for the acceleration on the y direction. Guess what, guys? There's no acceleration on the y direction. This thing is not moving up or down. There's absolutely nothing happening. So the acceleration on the y direction is going to be 0. So which means that this expression is going to be equal to that expression. So we got 2 equations. All right, so sum from the angle. We got 2 unknowns. Actually, we got 3 unknowns. We don't know t, we don't know m, we don't know theta. Then we were able to generate 2 equations. All right, so here's what I'm going to do. I'm going to get rid of t. I'm going to take this equation divided by that one. All right, so this equation is going to get divided by that. All right, so which means that I'm dividing both sides. This that t's will cancel, m's will cancel. This is kind of neat. You know that sine of the theta divided by the cosine of the theta is going to be the same as the tangent of the theta. All right, so we came up with that expression. So acceleration divided by g is going to be the tangent of the theta. So isolate the angle from here. Taking the inverse out of the tangent, both sides, and that's it. Just okay. So lastly, the acceleration. Oh, that's weird. Evidently, I had the awareness that this thing was accelerating in the forward direction because it was fairly obvious. Initial speed is going to be 0. The final speed is going to be 60 miles per hour, whatever that is, 26.78 meters per second. All right, so I'm going to do a back substitution right there. This is the final expression, now the numbers. All right, so the speed is going to be 60 miles per hour, so it's going to be 26.78. Divided by g, it's roughly about 10, big old 10, roughly about 10. Time is going to be 8 seconds. And the angle is going to be very small. It's going to be less than 1 degree. Okay, so extra credit is extra credit. If you can handle it, that's fine. It's not a big deal. Okay, so the upgrade test will have the same flavor. Obviously, they're going to be much, much easier than this. You have to study the way to do these problems.